Good morning, students. See, you might have come across a topic called projectile. In that projectile motion, you would have studied. In that oblique projection and horizontal projection, you would have studied, right? Whether it is in oblique projection or horizontal projection. Before proceeding into the chapter, our main aim is to find out where do we use the equations of motion in the oblique projection. So many students have confusions in the case of projectile motion, right? So now, before that, let us learn what is meant by projectile. So projectile is an object or a body which has been thrown. We should not use the word thrown, which has been projected at an angle less than 90 degree, but it should be thrown with an initial horizontal velocity and under the force of gravity. Then that object is said to be a projectile. And if that projectile takes a path of parabola, then that motion of the projectile is said to be a projectile motion, right? Okay, so example, javelin throw, shot put throw, and arrow aimed. So these are all the examples, even hitting a cricket ball. So they all make a parabolic path, a curved path from the point of projection, right? From the point of projection. So this is all about the projectile and the projectile motion. Now what is meant by an oblique projection? So if any object or the projectile is projected from the ground level, which makes an angle theta with the horizontal surface or horizontal direction, right? That type of projection is called as oblique projection. So in that oblique projection, we have got some subtitles like path of the parabola, the resultant velocity, the maximum height reached by the projectile, the time taken to reach the maximum height, time of flight, then the horizontal range, etc. Okay. So when we go for the resultant velocity to be found out, now we have to draw a diagram for that. So always remember, if this is the projectile and if this is thrown with an initial velocity u, this velocity will have two components of velocities. One will be along the horizontal direction, which is called as horizontal component of velocity or horizontal velocity. Another component will be in the vertical direction, which is called as u suffix y, or the vertical component of velocity or the vertical velocity, right? Here, this horizontal velocity, whenever the object is projected or the projectile is projected from an angle theta, right, from the ground level. So now, I say two components of velocity are acting in the projectile. Now this component, u suffix x, the horizontal component of velocity, will be always set at different points of the parabolic path. But this velocity u suffix y will keep on changing accordingly. If it is projected from the ground level to the maximum height, it will be decreasing, and at maximum height it will be 0. Whenever the projectile is falling towards the earth, then uy will be increasing and it is towards the earth because of gravity, right? So now let us look on to the diagram. This is y-axis, this is x-axis. The object is projected with an initial velocity u, like this, making an angle theta with the horizontal direction. Now this u has two components, u suffix x and u suffix y. This u suffix x is equal to u cos theta after some doing some calculation, and uy is nothing but u1. So u1 is the initial vertical velocity at this point, which is also equal to u sine theta. So the value of ux, uy are given, right? Now, if this is the point O, this is the point A, this is the point B, this is the point C. So at this point O, the vertical component will be u1, the horizontal component will be ux. At this point, the vertical component will be decreasing to u2, the horizontal component will be ux. At this point, there is no vertical component, that component u3 will become 0, and this will be the horizontal component. At this point, the vertical component will be increasing as u4, the horizontal component will be same. So at different points, ux will be same because there is no force acting on the u suffix x. And the vertical velocity keeps changing here. As it rises, it decreases, and at maximum height becomes 0. As it falls, it increases and reaches the ground, right? Now, this is all about the diagram. Consider when the projectile starts from the point O to the point A, it takes time t1. When the projectile from the same ground level to the maximum height, the time taken by the projectile is t suffix m. From the same ground level to the point where it hits the ground, the time taken by the projectile is t suffix f. So time of flight, t suffix f, is called as total time taken by the projectile from the point of projection to the point where it hits the ground. And tm is the time taken by the projectile from the point of projection to the maximum height, so at which the vertical velocity becomes 0, right? Now, if this is the maximum height, now I say we are going to use the three equations of motion, that is v equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. So where we are going to apply this equation of motion in this oblique projection. Okay. First, we are going to find out the resultant velocity at this point A. So here, the resultant velocity v is acting at this point A. Now let me draw the diagram, the resultant velocity, which makes an angle alpha with ux. So this is u2. Now let me draw a perpendicular line on ux. So opposite side, hypotenuse, adjacent. Here I can use Pythagoras theorem. So according to Pythagoras theorem, v square is equal to u2 square plus ux square. Since this is parallel to u2, I am taking this as u2 ux. Okay. So v is equal to square root of u2 square plus ux square. Now you know the value for ux. So u2 square plus ux is nothing but u cos theta, that whole square. Now what is u2? To find u2, we have to go for the equation of motion. V is equal to u plus at. Here v is the final vertical velocity at the point A. U is the initial vertical velocity at the point O. So v is equal to u2, u is equal to u1. Since the body rises against gravity, A is equal to minus g. T is equal to the time taken from this point to this point A is t1. So let me make this as u2 is equal to u1. u1 is also equal to u sine theta. So remember that, minus gt1. So again, u2 is equal to u sine theta minus g t1. So let me substitute the value of u2 here in this equation. So I get the resultant velocity as u2 value u sin theta minus gt1 the whole square plus u cos theta the whole square. So now we have seen the equation of motion v equal to u plus at here. Okay, now next let us find out the maximum height reached by the projectile. So we need to find out the h max at this point B. So to find out the maximum height, we have to use an equation of motion v squared is equal to u squared plus 2as. Here v is the final vertical velocity at this point B, which is nothing but u3 which is equal to 0. U is the initial vertical velocity at the point O, that is u1 which is equal to u sin theta. A is against, since it is against gravity, it is equal to minus g. S is equal to the maximum height reached by the projectile. Now let me substitute the value here. So u3 squared is equal to u1 squared minus 2gh maximum. So this becomes 0. U sin theta the whole square minus 2gh maximum. So 2gh maximum is equal to u squared sin squared theta by 2g. So h max will be equal to u squared sin squared theta by 2g. So this is the maximum height reached by the projectile. Okay, again. Now, if you want to find out the time of flight, now to find time of flight, I am going to use this equation of motion. S is equal to ut plus of at squared. So S is the point or the height when the body reaches, when the projectile reaches the ground. So h is will be equal to the height, but here when it reaches the ground, the h will be equal to 0. So and u is the initial vertical velocity, which is nothing but u1. It's nothing but u sin theta. A is again minus g. T is tf, the time of flight. So let me substitute the values here. 0 is equal to u sin theta into tf minus of g tf square. So let me make this equation of g tf square is equal to u sin theta into tf, 1 tf cancel. So tf is equal to 2u sin theta by g. So this is the time of flight. So let me write the time of flight here. 2u sin theta by g. Okay. So I think to find out these things, we have used 3 equations of motions. Thank you.